Hello students, welcome to Sentences online classes. Students, we are working from home. So today we will solve the exercise 10.2. All the concepts and formulas I have already told you in the previous video. So now look at the very first question, which is find the magnitude of the given vector. So I told you in the previous video that whenever we have given a vector in components form, then the magnitude of the vector b would be under root of the number which is coefficient of I, that's square, the number which is coefficient of j plus that's square, and which is the coefficient of k cap, that's square. So modulus of b would be 4 plus 49 plus 9. So that would be under root 49, 9, 58, 4, 62, under root 62 answer. Now look at the question number second. Write two different vectors having same magnitude. So there could be n number of vectors whose magnitude could be same. So I am writing, suppose this is the vector a equals to 2i plus 3j plus 4k. Okay, now I am writing another vector b. So I am just interchanging the coefficient of I, j and k. So 4i plus 2j plus 3k. But these both will have same magnitude. As you can see that modulus of a would be under root of 2j square 4 plus 3j square 9 plus 4 square 16. Same, the magnitude of b would also be under root of 4 square 16 plus 2 square 4 plus 3 square 9. Both are same. So vector a and b are two different vectors having same magnitude. But now look at the question number third. This is write two different vectors having same direction. Suppose I have a vector a, I cap plus j cap plus k cap, and another vector b, 2i cap plus 2j cap plus 2k cap. But both are different vectors. Now we have to check the direction cosines. So the direction cosine of vector a. So first of all, a, b, c direction ratios are 1, 1, 1. So l, m, n would be, these are a upon under root a square plus b square plus c square, b upon under root a square plus b square plus c square, and c upon under root a square plus b square plus c square. It means what a is 1 upon under root 1 square plus 1 square plus 1 square. It means what 1 upon under root 3, 1 upon under root 3, 1 upon under root 3. So these are the direction cosines. Okay, now check the direction cosine of this. So direction ratios a, b, c are 2, 2, 2. So now l, m, n would be, right now I am doing directly. So a upon under root a square plus b square plus c square. It means what under root 4 plus 4 plus 4. It means under root 12. 2 upon under root 12, 2 upon under root 12, and 2 upon under root 12. So 2 upon under root 12 would be 2 into 2 into 4, 3, sorry, that would be 2 under root 3, 2 upon 2 under root 3, 2 upon 2 under root 3. So 2 will be cancelled out. So direction cosine of that vector would be 1 upon under root 3, 1 upon under root 3, 1 upon under root 3. So as we can see that direction cosines of this vector a and this vector b are same. If direction cosines are same, it means what? The value of cos alpha, cos theta, whatever it is same. So if hence they are making equal angles with the x, y and z axis, hence they are in same direction. So these are the two vectors who are different but are in the same direction. So students, please pause the video and note all these 3 questions down. Students, now look at the question number 5. So here we have given 2 points a and b. A is initial point and the coordinate of point a is 2, 1 and point b is minus 5, 7. Now we have to find the scalar component and vector component of the vector a to b. So first of all, ab vector would be equals to position vector of b, point b, minus position vector of point a. It means what? The vector form of point b minus vector point of point a. So the vector form of point b would be minus 5i plus 7j, and there is no z coordinate, so we could write 0 into k cap minus the coordinate, the vector form of point A would be 2i plus j minus 0 into k cap. So that would be minus 5i minus 2i, so minus 7i plus 7j minus j minus 6j cap and 0 0 0, doesn't matter. Okay, so now this is the vector AB. So here scalar components are minus 7 and minus 6, and vector components are minus 7i minus 6j cap. Okay students, now look at the question number 7, that we have given a vector A equals to I cap plus j cap plus 2k cap, and we have to find a unit vector in the direction of this vector. So beta, we have to find A cap, and the formula of A cap is A vector upon modulus of this vector. So first of all we will find the modulus of A. So that would be under root of 1 plus 1 plus 2 square is 4. It means what? Under root 6. So now A cap would be vector A I plus j plus 2k cap upon under root 6, and we can write like I cap upon under root 6 plus j cap upon under root 6 plus 2 upon under root 6 k cap. Answer. That would be the unit vector in the direction of vector A. Now look at the question number 8. We have given a point P and Q, P with the point 1, 2, 3 and Q with the point 4, 5, 6, and we have to find the unit vector of vector PQ. So first of all we will find the PQ vector. So the PQ vector would be position vector of point Q minus position vector of point P. It means what? x2 minus x1 into I, y2 minus y1 into j, z2 minus z1 into k. So that would be 4 minus 1, 3i plus 5 minus 2, 3j, and 6 minus 3, 3k. But this is the PQ vector. So for unit vector we need to find the magnitude of this vector. It means what? Under root 3 square 9 plus 9 plus 9 under root 27. So unit vector of PQ would be PQ vector upon modulus of PQ. It means what? 3 upon under root 27 I cap plus 3 upon under root 27 j cap plus 3 upon under root 27 k cap. Root 27 would be 3 under root 3 I plus 3 upon 3 under root 3 j plus 3 upon 3 under root 3 k. So that would be cancelled out. So answer would be I cap upon under root 3 plus j upon under root 3 plus k cap upon under root 3. So this is the unit vector in the direction of the vector PQ. So students, please pause the video and note it down. Students, now look at the question number 9. We have given two vectors. This is vector A and vector B, and we have been asked that we have to find a unit vector in the direction of vector A plus vector B. It means A plus B cap. So for that, first of all we will find A plus B vector. So that would be 2i plus I, 2i minus I, that I cap, minus j plus j, that would be cancelled out. 2k minus k, it means what? K cap. So this is the vector A plus B. Now find its magnitude. So that would be under root 1 square plus 1, it means what? Under root 2. So A plus B cap would be A vector plus B vector, it means what? I plus k upon under root 2. It means what? I upon under root 2 plus k upon under root 2. Answer. Okay? Now look at the question number 10. Find a vector A. Find a vector in the direction of vector A equals this, which has magnitude 8 units. We have to find a vector such that his magnitude should be the 8 times of this vector. So we will solve it by the unitary method. We will find out the value of 1 unit, and then whatever unit we have been asked 8, then we will multiply by the 8. So first of all we will find the 1 unit. It means what? Unit vector of vector A cap. So A cap would be vector A upon magnitude of this. So but this is 5i minus j plus 2k cap upon, the magnitude would be A is 25 plus 1 plus 4. Okay, this is 30. So A cap would be 5i upon under root 30 minus j cap upon under root 30 plus 2k cap upon under root 30. So now required vector, suppose that is vector b, that was the 8 times of this vector. So vector b would be 8 into 5i cap upon under root 30 minus j cap upon under root 30 plus 2k k cap upon under root 30. It means vector b would be 40i upon under root 30 minus 8 upon under root 30 j cap plus 16 upon under root 30 k cap. Okay students, now look, it's very easy questions. Look at the question number 11. Show that given these two vectors are collinear. So the condition for collinear was 2. या तो we could say a equals to lambda v या b equals to lambda a, or we can show that a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2 to a scalar number, any number lambda. So I am solving that. So a1 it means 2 upon minus 4, b1 minus 3, b2 6, 4 upon minus 8. Beta, all these are equal or not? These all are equal to and equal to what? Minus 1 upon 2. Hence vector a and vector b are collinear vectors. Okay students, please pause the video and note them down. Students, now look at the question number 14, that show that a vector a I plus j plus k is equally inclined to ox, oy, oz. It means on x-axis, y-axis, and z-axis. Suppose these are my 3D space, x-axis, y-axis, and z-axis, and this is this vector, a vector. So we have to prove that it is equally inclined. It is making same angle. It is making, if it is making alpha angle with the x-axis, then it should also make alpha angle with the y-axis and alpha angle with the z-axis. It means what? Direction angle should be same. If direction angle is same, then obvious direction cosine would be same. If we show that the direction cosine of this angle are same, it means what? It is equally inclined to all axes. So beta, here direction ratios are a, b and c are 1, 1, 1. So L, M, N, they would be a upon under root a square plus b square plus c square, 1 upon under root 3. M would be b upon under root a square plus b square c square, 1 upon under root 3. So beta, value of L, M and N are equal. It means what? Hence vector A is equally inclined to all three axes. Okay students, so now please pause the video and note it down.